Hello, my name is Olu. I'm sure that by now many of you will be preparing for your mock exams or maybe even preparing for the main GCSEs and A-level exams. Well, people have been asking me, oh, can you please send us solutions to the 2018 past paper for Mathematics AS, AQA and stuff like that? Well, the truth is we are not allowed to release the question papers of the last exam. It would get released very close to the main exam, just so you can use that to practice and see how prepared you are. So 2018 past papers would be ready for you to see, would be public by the second week to the exam, just so you can test yourself and see whether you are now ready for the 2019 exams. But then we still want to learn from it, right? So today's video would be about questions that are in a way related to questions from the 2018, because believe it or not, regardless of whether you're prepared or not, you just want to be able to say you can solve some of these questions. So let's see what the first question could be like. This is not I'm not giving you the question, I'm just giving you what the question looks like, because I have the paper for last year with me, but I'm not giving it to you. I'm just giving you questions that look like questions that are from the topic, basically. So the first question would be about indices, surds, and all of that. Can you solve this one? So simplify, okay, square root of 72, right, plus square root of 200, and put your answer in its simplest form. So what would you do? Surds. Think about it. What would you do if you have to leave your answer in the form something root 2 or in the simplest form? What would you do? Well, a number of people would claim that this is easy, and rightfully so. But then what you need to do is realize that this number is a familiar, we are very familiar with the number 72. It comes from 36 times 2, right? So that is actually 36 times 2. And this number is a familiar number as well. It comes from the number 100 times 2. Notice that 36 is a square number, 100 is also a square number. So this means square root 36 square root 2 plus square root 100 square root 2. No one knows what to do with root 2, but of course we know square root of 36 is just 6, so that's 6 root 2. And we know square root of 100 is just 10, so that's 10 root 2. Now at this juncture, I need to let you know that when you're dealing with surds, take it as algebra. So pretend that these were just x. Pretend that this root 2 here is just x. 6x plus 10x would be 16x, right? But instead of 16x, we know that what we have is actually root 2. So the answer here is 16 root 2. Okay, now that is simplifying surds. It could get more complicated. Let us see more examples. So simplify root 50 plus root 102, okay, divided by root 27 plus root 162. Okay, now this we need to simplify that. So the first thing you want to do again is to see how you can break these numbers down to things that look like, to the surd form, to the lowest possible surd form. Right, so let's start with the 50. You do remember that 50 is just like 25 times 2, right? So that 50 there is actually root 25 root 2. Okay. What about 102? What does that remind you of? Okay, I know some people will struggle to figure out what that is. So 102, what does that remind you of? Okay, I think I made a mistake. I actually wanted to put 108. So that should have been 108. I'm sorry, my bad. You have to be patient with me. I'm trying to make questions up that look like the real questions. It's not easy. Okay, so that's 108. Now, you may again have to keep dividing. So how do I quickly know what this goes down to? Divide 108 by 2. What do you get? When you divide 108 by 2, you get 54. So it's obviously not a square number. Let's divide 108 by 3. And that's 36. So that's the square number. So that means I should actually say 108 is root 36 root 3. Okay. And divided by root 27. Let's see what 27 goes down to. Divide 27 by 2. It doesn't give you a square number. Divide 27 by 3. And it gives you a square number, 9. So 27 goes down to root 9 root 3. And root 162, let's see. 162 divided by 2, 81. So very quickly we could see that that is root 81 root 2. Okay. Now if I rewrite these ones that I can easily tell what the square roots are, root 25 root 2 just means 5 root 2. That one there, root 36 root 3, means 6 root 3. And if you permit me, I would like to write this before that, just so that I can keep to the same arrangement. So that's 9 root 2, and that's 3 root 3. Right, so this is a question. But what we want to do is we want to simplify this. So how do we simplify further? Now bear in mind that in the exam they could give you that and you would have to work your way down, or they could give you this and you would have to finish it up, or they could give you this bottom one like this, but the top one could be like that. So you have to simplify the top one first before you proceed. So we are happy with where we are now. We just want to proceed. So I will tell you that what you need to do now is to multiply top and bottom by the conjugate of the denominator. Do I need to repeat myself? Okay, so the conjugate of the denominator is what you're going to multiply this top and this bottom by. Now when we say conjugate, conjugate simply means if you see a plus, put a minus sign. If you see a minus sign, put a plus. So the conjugate of the bottom means that 9 root 2, I'm not going to say plus because it has to be the opposite. So minus 3 root 3. So let's do this. So this is that one. I will now be multiplying by the conjugate of the bottom. So that's 9 root 2 minus 3 root 3. 9 root 2 minus 3 root 3. Right, so we are happy to multiply the top by the conjugate of the bottom, and we are happy to multiply the bottom by the conjugate of the bottom. Right, now this is a pattern you need to practice just so you can get very, very familiar with this. Now, do you remember how to expand? Again, pretend that this is just algebra. Wherever you have root 2, it's just like you have x. Wherever you have root 3, it's just like you have y. So 5x plus 6y into bracket 9x minus 3y. Exactly how you would do that is what you're going to do here. But then, just so you remember how to expand brackets, it is first, outer, inner, last. You just need to practice that if you've forgotten. But of course, at this level, most of you would still remember how to expand. So 5 root 2 times 9 root 2, okay? So I'm just going to put an arrow there to guide us. So that's the first, okay? 5 root 2 times 9 root 2. 5 times 9 is 45. Root 2 times root 2 is 2, right? Square root of 2 times square root of 2 gives you 2. So 5 times 9 times square root of 2 times square root of 2, that is 45 times 2, which is 90. Plus, first, we've just done first. Now we need to do outer. So that's this multiplied by the outer one as well. So that's 5 root 2 multiplied by negative 3 root 3. So I know I've put a plus here, but the answer for that multiplication might end up becoming negative. 5 times negative 3 is negative 15. Root 2 times root 3, well, root 2 times root 3 just is root 6. Why is that? Because if this is an x and that is a y, x times y cannot become x or y. It has to be just xy. So 5x times negative 3y would just give you negative 15xy. But instead of writing xy, I'm just going to keep it as root 2 root 3. Now, root 2 root 3, from what you've seen here, is the same thing as going backwards. So root 2 root 3 would go back to root 6. So that's just root 6. Okay? Now, plus inner. So we've done first, we've done outer. Now inner, so this to this. We multiply them. Inner. So 6 root 3 times 9 root 2. Both positive numbers, so we expect a positive. 6 times 9 times root 3 times root 2. 6 times 9 is 54. Root 3 times root 2 again is root 6. So that's 54 root 6. And the final one, because we've just done first, outer, inner, now the final one is last, because this is the formula, FOIL. First, outer, inner, last. So let's do the last one, which is the last term here, and the last term in the second bracket. So that is 6 root 3 times negative 3 root 3. 6 times negative 3 is negative 18. Root 3 times root 3 is 3. So by the time you multiply root 3 times root 3, you get 3. Multiply that to 6 times 3, 18. So that changes this 18 to 54. So I shouldn't have been quick to write 18 because that needs to become negative 54. If you permit me, I'll just do that. Okay, 6 times negative 3 is negative 18, times root 3 is negative 54. Sorry, that's 57. No, 54 is right. Why am I confused? Now, how about the bottom one? Well, we could go through the process of doing first, outer, inner, last, or we could just remember something here, that there's a reason we've said multiply by the conjugate of the bottom, and that's because that gives you completing, sorry, that gives you what we call the difference of two squares. So this square minus this square, that's what you get. But let's do it as if we're not sure, so we can see what happens. 9 times 9, because first, so 9 times 9 times root 2 times root 2. 9 times 9 is 81. Root 2 times root 2 is 2. So 81 times 2 is 162. Again, outer, so that's this 9 root 2 times 3 root 3 this time around. So 9 times negative 3 is negative 27. Root 2 times root 3 is root 6. Inner, so that's this and that. 3 times 9 is 27, positive. Root 3 times root 2 is root 6. The last, because we've just done first, outer, inner, then last. 3 root 3 multiplied by negative 3 root 3. 3 times negative 3 is negative 9. Root 3 times root 3 is 3. So you have negative 9 times 3, that's negative 27. You would notice that the middle terms here would cancel out. You have negative 27 root 6 plus 27 root 6. It's like saying negative 27x plus 27x. So that would become 0. You're left with 162 minus 27 at the denominator. So that leads us to what we can call the final solution, which is, I will just write that out very briefly, just so you can see what it's like. 90 minus 15 root 6 plus 54 root 6 minus 54 over 162 minus 27. So that is what we need to simplify. But of course, I'm sure you remember that again, these two can go together. So when you have negative 15x plus 54x, what does that simplify to? It's just 54 minus 15, yeah, and that's 39 root 6. So you have 90 minus 30, plus 39 root 6 minus 54 over 162 minus 27 is 135. Also, take note that this and this can be added up because they are both numbers. So 90 minus 54 would give you 36. So you now have that to give you 36 plus 39 root 6 over 135. Now, something else is happening here. There is a common factor, and that's 3. So if 3 is a common factor, we can factor 3 out of all of this. So when you divide 36 by 3, you're left with, so let's divide everything by 3, okay? 36 divided by 3 gives you 12. 39 divided by 3 gives you 13, so you have 13 root 6. 135 divided by 3 gives you 45, and that is the final answer. You either write it like that, or you write it as 12 over 45 plus 13 over 45 root 6. And if that's the case, 12 and 45 have 3 in common again, so that becomes 4 over 15 plus 13 over 45 root 6. But as long as you get to this point, you've got the mark for it. Right? Okay. Now, that kind of question was for 6 marks in the exam. I mean, everything we've just done so far was for 6 marks in the exam. So you can imagine what you would gain at the start. And it's not difficult to get it because it's only swords, really. Okay. We move to the second type of question, which is about graphs, curves, and all of those coordinates things. I know many of you would really at this point be struggling to remember a formula about how to get the equation of a curve at, when a line passes through it and stuff like that. But hey, let's look at an example. So let's say you have a line. So you have the equation of a line. Now this is a question. 3x plus 7y, okay, minus 4 equals 0. That's the equation of a line. And there is a point, let's say point A, minus 2, 5. Okay. Now, if you are told to find the gradient of this line, so you've been given two things, equation of a line and a point on the graph sheet, minus 2, 5. And you're told to find the gradient of this line, what would you do? So many people struggle the moment you write the equation of a straight line like this, they struggle. But they wouldn't have struggled if the equation was written like this. Y equals mx plus c. So if you struggle, if you don't struggle with this, then try to rewrite this in this manner and you'd find out that your gradient would stand out clearly. Because we all know that when you have y equals mx plus c, m is your gradient. So whatever happens to be in front of x when you write it this way is your gradient. So let's solve that question. 3x plus 7y minus 4 equals 0. I would like to make y the subject of the formula, so everything else has to leave, okay? The only thing I want to see here is my y. But you need to know how to do that. So the first thing you want to do is to add 4 to both sides, because that's the first thing you would do to get rid of negative 4. Add 4 to both sides. So when you add 4 to this side, it cancels the negative 4. You're left with 3x plus 7y equals 0 plus 4 is 4. But remember, we want to make y the only thing standing here, so we don't want 3x there, for God's sake. I agree that we also don't want 7 here, but be honest with yourself. Which of these can you get rid of faster, the 3x or the 7? Okay. Obviously, 3x is the one that you can get rid of faster because y is actually holding 7 to its heart, but 3x is kind of away from it. So we will quickly steal away the 3x by subtracting 3x from both sides. So that cancels the 3x you have there. You're left with 7y, but then because you said subtract 3x from both sides, so you have 4 minus 3x. Now this is what we have, but are we done yet? Of course not. We want to have y alone, not 7y. So what is the thing you can do to that 7 to get rid of it? Can you subtract 7 from the left hand side? Can you subtract 7 from it? Obviously you can't, because you only subtract what was added to get rid of it, or you only add what was subtracted. But in this case, the 7 is not being added to y, and it's not being subtracted from y, it is multiplying y. So the only thing you can do is to do the opposite of multiplication, which is division. So we are going to now divide both sides by 7. It is when you try to do that that the 7 can be cut off. You're left with y on that side, and you're left with 4 minus 3x divided by 7 on this side. But we wouldn't leave it this way. Rather, we are going to split it completely. So y equals, if you have 4 minus 3x all divided by 7, is the same thing as 4 divided by 7 minus 3x divided by 7. It's the same thing. Okay? It's just like I tell you, if I say to you, work out 10 plus 4 divided by 2. Of course, 10 plus 4 is 14. Divided by 2 should give you 7. But you could choose to do it this way. 10 divided by 2 plus 4 divided by 2. And then that's 5, and that's 2. 5 plus 2 gives you 7. So you don't have to leave it that way. You can split the division. Okay? So in this case, we decided to separate 4 and negative 3x away. So the answer now is y equals, I'm going to write the minus 3x first. So minus 3x over 7 plus 4 over 7. Now, please, I want you to be the judge of this. Can you compare this to that and tell me what the gradient is? Obviously, the guy that has taken the place of m here is anything else apart from x in the first term. So that is negative 3 over 7. So the gradient is negative 3 over 7. So gradient is negative 3 over 7. And that's it. You've got the answer. You've got it. You've got it. Do not forget the negative. It is negative, and what that means is that it's actually going downwards. The slope is going downwards. Right. So if you can do that, that's great. But guess what? It's only 1 mark. But that's not a problem, because the step you followed up to this point would lead you to solving the next question. And that means that if you get this right, then you can get the others right. If you get this wrong, even though it's just 1 mark, trust me, you're going to lose the rest of the marks. So the next question would be talking about things like, okay, if this is a gradient for this line, what will be the gradient for a line that is perpendicular to it? What will be the gradient of a line that is parallel to it? Or if I've given you this equation of a line, and now you've worked out what the gradient of that line is, if I tell you that another line is perpendicular to this line, but passes through this point, how would you be able to give me the equation of that second line? Because obviously you now know 2 points it passes through, but I haven't given you the gradient of the second line. But I've told you it's perpendicular to this first line. Do you remember? Well, if you don't remember, it's okay, because I'm here for you. That's why I'm here. So, the question now is, find the equation of a second line which is perpendicular to the first line, which we've just done, and it passes through the point A, which we said was negative 2,5. Yeah, that is the question. So I will just give you a quick recap of what the equation of the first line was. So the first line, now this is why I said the answer to your first question would help you to get the second question right. And if your first question was wrong, you will definitely miss the answer for the second question. But sometimes the mark scheme could be very lenient. They could say that whatever your answer for the first question is, even though you've missed the mark for the first question, let's carry on with it and see if the student has used that wrong answer in the right way. But sometimes you don't have that leniency. Right, that's the first line. Now you've been told that the second line passes through the point minus 2,5 and it's perpendicular to the first line. So what is the equation? So I'm going to write it like this. The second line would look like this. Y equals mx plus c. So the question is, what is our m for the second line? And what is our c? If we know those two, then that's it. We've got the answer. Just plug in your m and c and leave it like that and run away. But what's your m? The key word in the question here is the word perpendicular. And you just have to remember that there is something significant about that statement there. And I think at this point, I would quickly give you a short briefing on that. Now, when you have two lines, one goes this way, the other one goes that way, and you're told that these two lines are perpendicular. if the gradient of this one is m1 and the gradient of this one is m2, just because they are perpendicular, we can now say that when you multiply m1 and m2, you must get -1. Take it, okay? Don't argue. Don't even ask why. Just take it in. You haven't got time. Just take it. When you have a gradient m1 and another gradient m2, and you multiply the gradients together, if they are perpendicular, then the product of the gradients must be -1. But then, most people struggle to use this knowledge. They cannot do it. They just can't do it, okay? Because I've taught several students and they just can't help it. This makes no sense to them. So what I tell them, and I'm going to tell you, is this. If two lines are perpendicular, then if you are told the gradient of one of them, then the gradient of the second one is the negative reciprocal. All right, just think about the word negative reciprocal. So when you want to revise this, or when you want to practice this question, first thing that should come to your mind is, oh, these two lines are perpendicular and I know the gradient of one of them, so the gradient of the second one must be negative reciprocal, negative reciprocal, negative reciprocal. Keep saying it, negative reciprocal. What does negative reciprocal mean? First, with the word negative, it means put a minus sign in front of it. Just negate it, okay? Negate it means that if it was a positive, now make it negative. If it was a negative, now make it positive, okay? Reciprocal means flip it, okay? Flip it. What was up should now go down, and what was down should now go up. And that's now your second gradient. Let's test you on this. I'm going to test you on this. So, this is going to be my first line, and this is going to be my second line. And I'm assuming that both of them are perpendicular. Okay, the two lines are perpendicular. If the gradient of this line is 2/5, what will be the gradient of the second line? If the gradient of the first line is -3/4, what will be the gradient of the second line? If the gradient of the first line is 3, what will be the gradient of the second line? If the gradient of the first line is -11, what will be the gradient of the second line? Now, this is something that you will have to remember all the day of your life, all the days of your life. As you grow old, you tell your grandchildren that it's always the negative reciprocal. Now, because these two lines are perpendicular, because they are perpendicular, okay, not parallel, perpendicular, we do negative reciprocal. So if the gradient of this one is 2/5, then the gradient of the second one would be, is that a positive? Yeah? So this is a negative.